some people out here during lunch, so you all skipped your lunch to come hear me talk, so I appreciate that. Thank you. I don't know what I'm talking about today, but I'll figure it out as we go along here, so I'm sure it should be pretty good. No, I'm kidding. Actually, it's funny, Eric was talking about breaking into buildings and using, the Proxmark and being able to get in through hid devices and everything like that. And a funny story at DerbyCon I just wanted to show. Chris Nickerson, one of his partners at Lars, came up to me at the Hyatt. He's like, "Hey, Dave, you have one of those like electronic cigarettes, right?" I'm like, "Yeah, why?" He's like, "Well, I'd like to try something real quick if you don't mind." I'm like, "Yeah, sure." So we recorded it, and this is at the Hyatt. You can see this here, and this is a door at the Hyatt, and they're both locked. There's a motion sensor on top, and you can push the doors. You can see it's locked up there. Motion sensor's on top, and if you puff the smoke into the cracks of the doors, takes 2 tries for me. Such a dick. Opens up the door for you. Triggers a motion sensor. Now it's funny because you can see on the other side. Wait, it's funny though. When Nickerson and I go into this, we didn't say anything. We just went and actually started blowing smoke into this crack at this door, which is the employees only section, right? And so we're blowing smoke into this. We open the door and there's like 3 Hyatt employees sitting there with like eyes wide open, smoke everywhere, and we're just like if I move slowly, you can't see me, right? This is what it looks like from the other side. Can you imagine if you're on the other side and you see that, what your reaction would be? I mean, I'd be like, what in the... No, not obvious at all. Funny story about that. So after DerbyCon, we're doing a physical pen test for a bank, and the bank wanted us to get into one of their branch locations, which has money, vault, get in the money, and hopefully like load bags of money into your car, which sounds awesome, right? So I've been waiting forever to try to do this smoke thing, like to blow smoke into the cracks of this retail branch bank that we're breaking into, and see what I could actually do. So it's 2 o'clock in the morning, we got night vision goggles on, we're doing all this crazy stuff, right? We don't need night vision goggles in any way, shape, or form. We have drones flying above, it's ridiculous. No reason for any of that, but it's just cool. And so I get to this bank, and I'm blowing smoke, the smoke from the e-cigarette up here, and at the same time, one of my other guys, Tristan's going around the building, kind of looking around surveillance-wise. And I'm spending like 10, 15 minutes trying to blow smoke to get through these cracks to get this motion sensor open. And I'm sitting there and I'm dripping more in. I'm like, there's like smoke everywhere. And the whole inside of this bank looks like it's completely fogged up completely from all the smoke. Well, eventually it opens. And so I open the door up and I'm like all excited. I'm like dancing. I just did the whole, vape smoke trick. And I walk in and I see my other guy, Tristan, sitting at the front desk sitting there laughing. And he's inside the building. I'm like, dude, how did you get inside the building? He's like, oh, the side door was open. I'm like, oh, man, that's ridiculous. So sometimes it's the easy stuff that gets you into. Just a quick background. I was formerly a Ghostbuster a while back. I actually built a proton pack, which is pretty interesting. It's got a subwoofer built into it and everything. It's kind of neat. My wife thinks I'm an idiot. But I've testified in front of Congress a couple times. I've authored a couple books, created the Social Engineer Toolkit. I'm on the news media organizations. Was in the Marines for a few years, deployed a couple of times to Iraq and a few other locations. And I've been here presenting at South Dakota. I think this is my 3rd year now, which is great. Always wonderful to get out here. It's basically the same exact weather as it is in Cleveland, Ohio. Actually, I think it's warmer here. It's like I'm getting a suntan. I can wear shorts. So I appreciate that. So this talk, when I came up with it, I look at talks, and I promise I'll blend technical and more higher level talk together here. But when I was coming up with the concept of this talk, I struggle with our industry because there's a lot of things happening where the industry moves in a lot of different directions, and it's really hard to see where it's moving to. You have a lot of things that happen in the news, like Heartbleed and Shell Shock and all these other things. You have a lot of companies that are looking at the security industry as the largest money-making industry that there is out there. So you have a lot of investments from different VC capital capitalist groups, people kind of influxing into this industry to get to it because they see a significant amount of money that they can make in this industry. And that's kind of disheartening because where we're moving as an industry, it's not necessarily a technology problem. Things that we do, the way that hackers break in, isn't a technology issue. It's just doing things that we've been taught for years and years and years. So when coming up with this talk, I look at what our mission is, right, and what we're trying to do in security. And really that's to try to detect them before a large breach happens, right? Before we have a major exposure or something that occurs that causes a cataclysmic effect in the organization that we're trying to protect. To detect something like that is important. To make sure that it's in the early stages of that is extremely important. And make sure that we're at least locked down enough where they move somewhere else, or make it significantly difficult that we can detect them in those early stages. And lastly, I mean, when it comes to working in an organization, I was a CSO for a big company for a number of years. And the biggest thing for them is they're not going to fix everything because they don't have enough money to fix everything. But if you can communicate things that are pretty high priority and you can get those things fixed, it, again, makes it harder and you're reducing your risk. So that's what our mission, I think, in security is. To detect and to hopefully respond and minimize the damage to our company. Prevention is kind of a interesting concept because everybody wants to prevent. We all have technology that can prevent. We have next generation firewalls and all these things that are coming out technology-wise to prevent. But at the end of the day, I mean, Eric will tell you, anybody that does pen testing on a regular basis, these things are ridiculous. We were just having a conversation last night, and it's great for Eric and I to get together because we talk about all of the bypasses that we have for all of the newest technologies out there. So he's like, yeah, I got this for Palo Alto. I'm like, oh, I got this for this, and we got this for this one, this for this one, so we go through, and it's just, when you're going through these tests, you see these pieces of technology, they don't really hinder us in any way. It's just a new way for us to hack that becomes a little bit more creative. So prevention's kind of out the window at this point. Application whitelisting, next generation firewalls, you name the preventative technology, and there's always going to be ways around it, but you hope to be able to detect those pieces as it's happening, which is the most important part. And so if you look at what we're trying to focus on, or at least what I try to focus on and communicate to everybody else out there in the industry, is that it's really the basics that save us. It's not the crazy technological advances in security. It's the basics that do it for us. I mean, network segmentation. I've heard, I think, 3 people in the prior talks talk about network segmentation and how often that does. I mean, for physical security devices, all the way to medical devices, to other areas. You segment your network where the sales folks don't have the ability to connect on RPC and NetBIOS. It makes it a lot difficult because the sales folks are always the ones getting compromised, right? So, you look at that, and that's something that, I think Marcus Raynham was talking about when he supposedly created the first firewall a number of years ago of network segmentation. And that was in the, 80s and 90s. Then you go to education, awareness, and training our users, and monitoring and detection capabilities, and secure coding practices, and just injecting security into what we do on a regular basis. Those are the things that we need to be focusing on as an industry, not all of this other stuff that we're hearing out there. And I'd like to play a video here really quick, and I'm going to try to use my mic to play it on this thing real quick. But this is something that kind of resonated with me. This is when I was on the Greta show. I'm not going to play my clip. I'm just going to show what General Dempsey said. But if you look at the dynamics of what we're seeing out there as far as attackers, the attackers, you always hear like, the attackers are sophisticated. They're sophisticated, and it's always associated to China or North Korea or Iran, and it's always Mandiant saying it's China or whatever, right? So you always hear this whole heavy sophistication. But if you look at these attacks, they're the same attacks that have been out there in the 90s, in the early 2000s. There's nothing sophisticated in any way, shape, or form. If they have somebody on their team, the hackers have somebody on their team that knows how to code something, anything, they're sophisticated. Like if they just wrote a Perl script, they're sophisticated. Anything that's custom is sophisticated. It's all sophisticated. Now, when it was the same stuff that we were doing back in the AOL proggy days, of doing things and booting people off of AOL, and that's sophisticated. Now, it's cool because now you can be sophisticated if you know how to do a couple lines of Python. And then if you want to do something really cool, just own a server in China, and now you're an APT. So that's where we're at as an industry. But I do want to say that we're so far behind the times, not only in the security industry, but in the government. When the government classifies these attacks as extremely sophisticated and we don't have an equal playing grounds, we're in trouble. Because these attacks aren't crazy. They're not sitting there popping O-days every single day to own our computers. The times of them burning 0 days go after more government-owned contracts like Lockheed and Boeing and those guys that are government-ready. That's the only time I've really seen a burn of a 0 day. But let's just look at this real quick. This is what General Dempsey said, and this is right before I went on to Greta. But it's interesting because this is the perception of our military. And he's right. It is an equal playing ground of where we're coming from. I completely agree with everything he's saying here.
Be incredibly destructive. It can be disruptive. It can disrupt, and it can destroy. And it can destroy hardware. It can disable critical infrastructure, which could lead to loss of life. And I think those capabilities are out there. And we have in every domain, Chris, we generally enjoy a significant military advantage. But we have peer competitors in cyber.
In other words, we don't have an advantage over that.
We don't have an advantage. It's a level playing field, and that makes this chairman very uncomfortable.
So why are we not ready? How devastating could this be? And this is just beginning. Tech expert David joined us. David,
I'm not going to talk about that. I don't show that part. I don't like seeing myself on TV. It's weird. It was a little plug there. Credit as a sponsor. No, what was interesting about that one, we were talking about terrorists getting the military or getting capabilities as well. So ISIS has been hacking into like social media sites and using it as a recruitment campaign for others. But hey, everybody's doing it now. But hey, now they're sophisticated because they guess someone's password on Twitter now. So it's like, but hey, they're state sponsored now or something because they originate from China. So that's where we're at now, because all of this stuff that we're hearing in the news now is all attribution. It's all about who did it and the sophistication that they used to do it. I mean, if you looked at these, did anybody actually look at the Sony malware? It wrote like 8 executables out. It was the sloppiest piece of code I've ever seen in my entire life, and yet it was the most highly sophisticated targeted attack we've ever seen in human history. Like, I was writing that stuff back when I was like coding MUDs in BBS days, and that's highly sophisticated. And so yet we're still trying to solve this problem of security. Like, how do we solve security issues? How do we protect companies? Because we're not doing a good job right now. But hey, we have people coming into this industry to try to do that. And so the major problem you see is whenever there's a new breach of something, whether it's Sony or Heartbleed or Anthem or Shell Shock or whatever we hear in the news. And I'm always on the news right on there afterwards, right? And I'm like, oh, Heartbleed's horrible and everything's not. But then people use that and they're like, hey, CFO or a CIO or CEO, I've been telling you guys for years that we're completely vulnerable to this and that we're totally screwed if we don't just invest in security, right? So then the CFO's like, oh my God, that's terrible. Like, we could be the next Sony. And then like, what do you need? And he was like, well, I need people and I need like $5 million in investment for technology. And so they go and they buy $5 million of technology when they have a horrible security program in the first place. And they slap all that stuff on top of it, and all of a sudden now it's supposed to be magically fixed, right? Technology does not fix that problem. And so if you look at the main exploitation methods, it's still the same stuff that I talked about last year here, and the year before that, and the year before that, and the year before that, since I think I was in the Marine Corps in 2000 to 2005. So the main compromise methods are going to be perimeter exploitation, so going after your web applications and CMSs and things like that, like WordPress. And then you also have, your client exploitation. Now, I was surprised because Java's actually declined in the amount of exploits that have been out. But if you actually look at the exploit market where you buy them, there's plenty of Java exploit 0 days out there still. So I don't think Java's gone by any stretch of means. Flash has been the really big one. But interesting enough, browser bugs have been up significantly. I think it was up 300%. Internet Explorer bugs were up 300% from last year, or from the year before from last year, 2014. So client exploitation, perimeter exploitation, and pivoting and post-exploitation. Those are the 3 things that are most commonly seen out there as far as exploitation. The most damaging isn't necessarily the user compromise. If you think about it, if I'm going to compromise a user, I'm going to try to take some data from them or whatnot, but my real value is pivoting into the rest of the organization and stealing as much as I possibly can, or getting access to sensitive data or keys to the kingdom or whatever. And so if you look at that, our biggest risk is going to be in this pivoting and post-exploitation detection scenarios, or in the initial compromise piece. And so we face a problem. The industry itself is focused on the necessity and need for technology. We face a problem because we focus on trying to expand our security team and get more people in order to house and support the new technology that we bring in. And we're also focused on identifying the threats faster when we don't have any programs in place. My biggest example, and I always get this question, I do some work for a company where they have a thing where you can be like an expert and recommend things. And the one that I always get is, hey, which DLP solution should I buy? And my response back is none, because I guarantee you don't have an information classification program, right? It's like, well, no, but we need to be able to do it right now for compliance reasons. I'm like, okay, well, then whatever. But, DLP is a prime example because DLP doesn't work unless you have an understanding of where your data resides at and if it's classified in some way, shape, or form. So DLP is just an overglorified regular expression for social security numbers and credit cards. That's all it is right now. So, when you look at that, if you don't have a program established, there's a lot of issues that come along with it. And for me, security is not a technical problem, it's a social one. And it needs to be communicated that way. When we communicate security, it has to be about educating the people, educating the company around us of what we're doing, not implementing the latest and greatest firewalls out there. So we need less solutions, we need less people focused on those pieces of technology, and we need to focus on industry that communicates more to the business of what we're doing. And so, speaking on the front of technology, I like having fun and going in and breaking into things on a regular basis, right? So there's a lot of tools that I write, and I'm sure a lot of you folks have used them, the Social Engineer Toolkit, or Auxiliary, and a few other ones. So when I talk about technology, I also like to break it as well. So I'm going to talk to you a little bit about both defensive tools that I write and offensive tools that I write that you're more than welcome to use. And I'm also going to show you a new one that I'm writing called the Pen Testers Framework that I should be releasing in the next 2 weeks or so. So I'll get into that here. One interesting one is chips. Has anybody heard of chips yet? It's a new one that we released a couple of weeks ago. It's the shared host integrated password server. And one of our consultants, Jeff Walton, wrote this one, which I love. It's cool when we're on a pen test and we're like, listen, I'm just tired of breaking in the same way over and over and over again. Can we just write a tool that fixes that for companies for free? So that's what we do. That's what we did here. And it's funny how we came up with the name Chips. One of our guys, Alex, won a chip eating contest. I think he ate like 17 baskets of chips at one point in time. And so we're actually going to call it Chips. But then we're like, well, it's kind of messed up that we're going to be calling Chips over. Anyway, so we end up recalling it Chips. So that's how the evolution of our tool names come together. So one of the common methods that we use to break into organizations is pivoting and post-exploitation based off of information that we gain from a system. So, hey, we'll compromise, computer A, and the computer A has a local admin hash that then we can use for the rest of the organization, right? Same thing goes for Linux. Linux, you grab the shadow file, and from there you pivot and you go to the rest of the systems because all of the passwords are the same. So, in this case, when we look at what we're trying to accomplish with this, is anybody familiar with like CyberArk or things like that, where you can rotate passwords and have a centralized way? Well, we try creating more of an open source platform like that. And so what Chips does is we wrote it's all open source. It's Ruby driven. And what happens is that you have endpoints, Linux servers, Cisco devices, whatever you want to covered under Chips. And it'll randomly rotate those passwords however long you want to. You can do it every 10 minutes, every hour, every 2 hours, every 2 days. But what it does is it uniquely randomizes all the passwords on each one of the systems and stores them centrally in one of their core servers. Now, the way that it's actually handled is that the Chips server handles the randomization, the password generation. These, for lack of a better term, are dumb clients. And so anything that can support SSL will support what can use Chips. So Cisco devices, you can run Cisco devices for randomized passwords. You can use Windows machines. You can use Linux machines. Anything that has SSL support can support an endpoint or a connector for Chips. And so what happens is that if I compromise endpoint A, the password is completely different from endpoint A to endpoint B. Or if I compromise a Linux device, the password is completely different from Linux device A to Linux device B. All of them are essentially stored in that Chips server where you log in as an admin, and it has Active Directory integration, so you can do it based off of specific groups that have access to specific passwords over specific servers. Or you could have your own authentication scheme based off of Ruby. But in any case, when I do post-exploitation and pivoting, every password, whether it's a server, an endpoint, a workstation, a Cisco device, a Linux device, whatever you have in your infrastructure can be supported with that, so we can't do post-exploitation scenarios. And it's got a nice, good look and feel to it. You could do Active Directory integration and logging in. But here you can see, when we log in, you can see the previous password that's set, as well as the current passwords that are out there, and you can specify how many previous passwords you want to show. But really, it's an easy way to essentially manage passwords in an infrastructure that's easy to set up. The connectors are trivial to write. We already have 3 connectors already written right now, but there's more to come. We have our Cisco one almost done. But basically, like literally, you run the scripts on the machines, like a cron job or a specific group policy task that'll schedule it for certain periods of time, and then it's automatically converting, sending it all back to your infrastructure real time to be able to handle that. So that was a really cool tool that we liked a lot, and it's we've had it implemented successfully in some very large organizations. The largest one that we have right now has about 27,000 servers deployed, and I think like around 100,000, 120,000 users or endpoints. Have it deployed successfully in, so we're continuously making improvements to it, but a lot of people have implemented it, and it's been cool to get feedback on it to help it. And it's great, it's open source. The first time we released it, I think someone had posted on the GitHub like, hey, you should use this instead of this because it's more secure, and like, cool, man, so we went and implemented that right away. So it's been a good project for that. don't know if you saw a recent release over Meterpreter SSH. This is one that I just released probably about a month and a half ago. But really, Meterpreter SSH was a kind of a cool one because from a post-exploitation perspective, I like tunneling a lot of my communications. And I actually wrote one where it would take, since SSH is a pretty forgiving protocol, I could take SSH, wrap it around HTTPS, and then tunnel that over a network. So then I could use SSH over HTTPS over to communicate and exfiltrate data out of a company. But I didn't release that because I figured that would kind of blow up the internet. So I just released SSH over Meterpreter. So someday I might release the SSH over HTTPS someday. But in this case, what this does, it's kind of neat, is it takes Metasploit shellcode. And so it'll take what's called a bind. If you're familiar with bind and reverses, a bind will bind to a local interface on a machine. Reverse will connect out to you. It binds to a local interface, and it wraps SSH around that bind port and then shoots it out of the network to you over SSH. So then you can establish an SSH tunnel real time using Metasploit over that local tap device. And what's also nice about it is that since we're dealing with Metasploit shellcode, you can encrypt the shellcode itself, inject it into memory real time, and not have it actually detected in any capacity. You can actually handle one of the new versions I'm working on with Meterpreter SSH is that it'll grab the AES encryption key when it establishes that SSH tunnel, and then it'll pass that, inject it, decrypt that into memory, and then from there you'll be able to have it. So there's no encryption keys that actually are housed in that piece of payload that you're actually injecting. And I'm actually working on doing that same thing over completely native PowerShell as well. So hopefully we should have a one-line copy and paste command that you could do that does all of this for you here soon. So I'm going to show you a demo of that real quick. And so all you do is I'll run this thing called monitor. And all monitor is doing is just waiting for my initial SSH connection to be established. And all it's doing is just sitting there waiting, polling, looking at SSH communications, and I give it a specific value that I use as a challenge in order to determine if it's there or not. And over here, I run my tool. It'll inject the shellcode into memory. It'll then take it, SSH will then take it, and these are all native Python modules. So it uses Paramiko, so you don't have to have like SSH installed on the Windows machine. You can also bycompile this so that it's an executable instead, so you don't have to have a Python interpreter on it. Then if you come over here, notice here encrypted tunnel is identified. It's going to go ahead and create the tunnel really quick, launch Metasploit, and then in a minute we should have a shell. Now what's kind of neat is since we're tunneling over SSH and we're binding to the local interface, you're going to see that the communications are actually localhost. You're going to see that I'm going to spawn a interpreter shell from 0.0.0.0. Is my local, or I'm sorry, 127.0.0.1, but I'm binding to 0.0.0.0. Take a second to launch. And we see I got our handler. Notice that I got my session from 127.0.0.1. Yep, works really well. That's all over SSH now. And it's fast. I mean, it's not slow in any way, shape, or form. It's pretty quick. So no real minimum lag or anything like that. It works pretty well. Then you can get that on GitHub. It's on our trusted site GitHub site. So all the source code, everything's there. I'm working on a new version of it now. So the encrypted piece where it actually grabs the encryption key. So the reason for the encryption, by the way, is if you have static shellcode sitting inside of a binary file, that's something that you can definitely grab a hold of. So what I'm going to do is basically create a small decrypt function inside of it where the entire code for Metasploit, or the entire code for the injection, SSH, everything is 100% encrypted with AES. And then it'll call out over SSH, grab the encryption key to decrypt it, and then decrypt that code real time in memory. So it's never really going to touch disk from a lot of those pieces that would be decrypted in a lot of cases. Next one I've been working on, and I just did a recent, really big update recently for artillery, and I'm working on a really big one right now. Artillery is on the defensive side, and if you're not familiar with it, I started artillery a number of years ago with the intent of being able to deploy artillery in a large scale to be able to determine a lot of early warning indicators of an attacker possibly. And so artillery has a lot of different features and functionalities built into it. And one of the most recent ones that I'm happy about is the feeds into multiple different IP lists and things like that, so you can get a little bit more idea of what's happening in your network. And so what it does is it does a lot of active honeypotting, where if you connect to a port, like you can install artillery and you run it, and then it'll spawn a bunch of ports and things like that to look for it. And if you connect to those ports, it'll notice you as an attacker. No one should be connecting to you on 1433 on a machine that's somewhere on your outside. The way that I like deploying artillery is putting artillery, throughout my networks in infrastructures in large organizations. But also, most corporations have IP blocks that they're not using. So, for example, let's just say, you have a, /C, 254 or 253 usable IP addresses in those, and I'm only using maybe 100 of those, okay? What I recommend in a lot of cases is you deploy artillery to those unused IP addresses. You just NAT all of those IPs to one specific artillery server. And then if you start getting blocks in there, just have it automatically do something like an automatic shun or something like that to give you some visibility so you can reduce a lot of the noise of the attackers out there. If I'm going to start port scanning your external network or your infrastructure, I mean, it's going to really start to hinder what I can do. If it automatically blocks me, that's even better. But it's a really easy way to deploy a lot of those. But it does a lot more too. It does monitoring of the file system. So if there's any changes or deviations to the file system, it has a SHA-512 database that it uses to monitor deviations and changes in the file system. So if something changes on your device, it automatically reports that back and notifies you. It can integrate into syslog, into email alerts, whatever you want to have as far as a format. It kind of handles all of those. One of the big things I'm working on right now is a server-client model where you can deploy multiple instances of artillery across the board and then have it report essentially back to a server infrastructure that can then essentially handle all of those. Then you can report all of that back to your SIMs or whatever you want to. So you kind of have one central point for a lot of those. This is kind of what it looks like. You can see the honeypots there once it's installed. And I probably picked the most horrible color that you can't see on the screen here. But if you look at what it's doing, it's setting up multiple ports here, and you can basically connect to those and use it. And I'll show you an example of this in a second. On the feed front, you can actually download these now. It's free for use or whatever you want to do with it. But I've deployed artillery servers all across the world, both in corporations that allow me to, as well as just like a whole bunch of honeypots deployed around the world. I think I have a total of like 172 right now that I'm using. And I got a whole bunch in like really weird countries that don't ask how I got those there. But they're all over the place for what we're getting as far as input feeds back from different attackers. And you can download that list. Whenever we get an identified attacker, it automatically goes to, I think on like a 2-minute interval, goes to binarydefense.com/banlist.txt. And you can use those IP addresses as additional feeds for attackers that might be out there. Additionally, what I recently added was the ability to put in source feeds from other threat intel feeds that are out there. Malware domains, IP lists of Zoo spotnet trackers, bad IP addresses, IP block lists, things like that. And so if you turn this feature on, which is on by default now, artillery will automatically go out and pull all of those feeds from those multiple areas and then pull it down for you so that you have kind of one big list of attackers that are out there. And artillery by default rotates out IPs every 2 weeks. So once IP addresses go stale after a certain period of time. So after 2 weeks or so, it'll recycle those IP addresses and kind of go from there. So I'll show you an example here really fast and how easy it is to install. And I'll blow my screen up here in just a second. So here we have artillery. And if you look at the file structure here, artillery has a few different files. The biggest one to install is just going to be setup. And so when you run setup, that's going to go through and configure everything. It's going to install everything under /var/artillery. And so I'm going to go ahead and run it. And it's asking, do I want to install artillery and have it automatically run when I restart? And my recommendation for that is yes. One thing to note is that artillery technically does work on Windows as well. But there's no service that I've created yet. So I'm working on that as well as my next release, that an actual service would be created on Windows as well, so you can actually get detection capabilities on your Windows servers as well and package them up, really easy to install, all that good stuff. And I'll release binaries for that too, so you can just double click and install it hopefully on your machines, and all of a sudden they got artillery installed. But as soon as you hit yes, we'll go ahead and hit yes. Now it's asking if I want to keep artillery updated. Now my personal preference for you is that I probably wouldn't. The reason is if you're going to configure things and keep it in a certain way, if I make an update that breaks your install, that's a problem, especially if it's in production instances. So I don't necessarily recommend it unless it's on servers that you want to continuously get code updates and things like that from the GitHub servers. So I'm going to go ahead and hit no in this case. I'll probably just remove that option, to be honest with you. One thing I recommend first is it's going to ask if you want to start artillery now. I'm just going to go ahead and say no because I want to configure a couple things first off. So if I go to var artillery, which is where it's located at, I do an ls, and here's the config file, okay? Now the config file contains all my configuration options for artillery that I want to configure that I may want to customize. Also, you have there's a feature inside of artillery to automatically ban an IP address. Let's just say you accidentally ban one you don't want to. You can remove that ban. You can restart the server itself. The database here contains the flat file database of the SHA-512 database. Any log files, things like that get stored in here. So it's a pretty simple structure for what's out there. And so I'm going to go ahead and edit the config. And notice here, one of the ones is monitor. And what monitor is it'll monitor specific file type changes. By default, I monitor var www and /etc. But you can monitor any type of directory structure you want to. And it'll go through and it'll pull looking for changes or deviations in those file structures and then report them to you. You can also exclude specific directories if you want to that you know are going to change. Then here we start getting into the honeypot ban piece. Now, when the honeypot gets created, it creates multiple ports, and you can specify those in options below. But what you can also do is that if you're running Linux, it'll automatically go and ban those IP addresses from communicating with you using like IP tables or whatnot to actually go and do it. In this case, too, we can also whitelist certain IPs. So if you have certain scanners or things that you know are going to be hitting this box and you don't want them banned, you can whitelist those IP addresses. You can do entire CIDR notations, too. So you can actually whitelist the entire CIDR notation. Here's the ports to spawn honeypots on. So the commonly attacked ones. So RPCnet BIOS, SSH, MS SQL, RDP, alternate HTTP ports, and then we have VNC and a bunch of other ones that go on 10,000 for Veritas.NET backup and the other ones that are out there. So those are the commonly attacked ports that are going to be used as an attacker that the honeypot sets up. You can set up email alerts. If you use email alerts, it'll want an SMTP username and password, or you can just specify nothing for password if you allow internal relays. The SMTP from, all that good stuff, what you're going to send it to. You can send intervals of how often you want them to send. Do you want an email sent every time someone connects to a port, or do you want intervals that bulks all the messages up into one and sends them to you? So you can have them sent, every hour, 2 hours, or whatever. So a lot of good functionality in there. It also monitors for SSH brute forces on your box. So if you want to check to see if someone's brute forcing, it'll send you notifications. FTP brute forces as well. Has some anti-DOS prevention in it, so it detects denial of service activities. Again, there's a lot of features in here that you can use. And here was one of my favorite ones. This is what we call a threat server. And what a threat server can do is it can act as your central repository for all of your other auxiliary sensors. So if you turn threat server to on, it will create and move your ban list file that you grab and move it to your web root directory. And then you can have all of your other auxiliary servers pull that threat intelligence feed from your server itself. So you can have multiple updated lists. And you can also have your auxiliary server go and pull out multiple threat feeds. So let's just say you have 20 auxiliary servers deployed across your network. You can have those auxiliary your core auxiliary server, go out and pull all of your banned IP addresses centrally, goes into the central feed itself, and then it'll say, hey, is this a duplicate? Okay, if it's not, then just add it to this. And then you now have a central feed of all of your locations and your areas that you can use. By default, it's going to go to binary defense, but you can have multiple ones. So if you notice here in the help file, or the little thing here, you can do a comma, the next website, comma, the next website, comma, the next website. So you can have as many feeds as you want to coming into here, and artillery automatically go and publish it out for you. And then here it'll do a couple checks for you. It'll look to make sure permissions are set right. If there's invalid permissions where it might create an exposure or vulnerability in your file system. You can also do syslog and remote syslog, so you can support all of those. And then here's where we get into the source feeds, where you can actually pull multiple feeds in from different locations. Right now, these are coded into what I call the core libraries within it, so you can't really add new feeds into it. But the next version, I added a place for you to be able to add your own feeds if you had other IP lists that you wanted to. So that should hopefully be done in the next few weeks. And once you're done, once you've configured everything, you can just run Python, restart server. If I look, you can see I have all my listening ports here or whatnot. It automatically responds too. So it sends a bunch of random data back to the attacker, just to make it a little bit more confusing. So you can see here I get a bunch of random data. It looks like a protocol. It's all randomized each time. So it adds a bunch of information to the scanners. It just throws everything off. If you ever nmapped a artillery server, it's horrible. I actually had a customer I was doing. He actually works for me now. I hired him after this. But I was doing a pen test for a customer, and they had a Raspberry Pi on, and so they had me plug into a network that I got DHCP on. I started scanning, and I'm like, what in the heck are you guys doing here? Like, it was horrible. I couldn't even do my pen test. And so I got owned by my own tool, which was pretty cool. And then if you're finished with it, you can always uninstall it. All right, so my next one that I'm releasing is called the Pen Testers Framework. And this is a new tool that when I do pen tests or I do an engagement, these are things that I create out of necessity because I can't handle like doing something and just typing the same commands over and over again every time I do it. I like to automate everything I'm doing. And so this is a new tool that I'm working on called the Pen Testers Framework. And I'm sure everybody here uses Kali Linux or uses their own distribution or whatever. The biggest challenge I have with any distributions, and Kali Linux by far is the most awesome distribution you can ever use. It's phenomenal. The team is great. But they run into the same problems as everybody else does, is that code changes all the time. Updates happen all the time. And I want access to that latest code. Like, for example, I was on a pen test, and MS-14068 came out, which is that big Kerberos bug that allowed a normal user to escalate permissions up to a domain admin. And I wanted the latest version of Responder because Responder had a uptime check via UDP Connect that allows you to check how long it's been since that server was rebooted to see if it was vulnerable to MS-14068. And so it wasn't in, obviously, the tool repositories yet because it was a new piece of code. So there's a period of time where you have to wait before your tools are updated, before it's in those Kali repos or whatever you're using as an industry. So what I did is I aimed to fix that. And what I did, just to show you, is I created a tool where anybody regardless if you're a programmer or not, can make your own modules of your own tools that continuously keep those up to date. And I'll show it to you. It already comes with its own, but you can see that's right. I kept it very much the same format as Metasploit. So I wanted to keep it as an easy operating, as easy as can be as from a learning curve. And what PTF will do, is the Pen Testers Framework will do, is it'll automatically detect what operating system you're using. So if you're using Debian or Fedora or Slackware, whatever you're using, it detects that platform, and then it'll show modules that are compatible with your specific operating system type. Okay? Now, if I go to Show Modules, you can see here I already have a bunch of tools in here where it'll automatically go. And what's neat is it'll automatically go and install all these for you, and then it'll keep it up to date for you. And it's regardless of if you have commands afterwards. Like, it's not some tools you can't just do like a git clone and then all of a sudden it works. You have to do things after that. Like Metasploit, for example, you need like 3,000 dependencies, right? So I created a programming. Go back this way. I made a programming language behind it that makes it super easy for you to be able to do all of your installs of your tools that you want to. And it doesn't need to be hacker tools too. It can be whatever you want to. It's what I call after commands that allow you to do post-installation things to finish things. And I also did one, which is called modules install all. And if you run that, it'll do either an install or update all of your tools as well. So basically, if you have a list of, let's just say, 40 tools that you use on a regular basis, it'll automatically iterate through all of those, install them, and update them, and keep them continuously updated for you throughout your entire progress. So you don't have to run one command through all of your different areas there. And just to kind of show you an example of it, I'll just go ahead and use modules, exploitation, and set, okay? So that puts me into the set category here. If I do show options, you can see here, since I'm using Debian, the install type is going to be off of Git. My install location can be set through the config file, but I put mine under pentest because I grew up with like iWax and Wapix and Backtrack, so I missed that pentest directory. So whenever I go to CD pentest, I like seeing, pentest, exploitation, SE toolkit. So it creates those directory structures for you, and all I have to do is type in either install or update. It'll both work the same, and I don't have an internet connection here, so it's going to fail. But it'll actually go through, install everything for you, and then all of a sudden now you have an up-to-date tool that runs everything that you need to. But if I just want to use you don't need to see anything anyway. The projector is cursed after you used it. Everybody else is fine, Eric, and you cursed it. But if I don't want to do this individually to each one, I can just run that install all update or update all module, and it'll go through and it'll keep everything up to date for me real time. Now the big perk about this is this. In order for you to write your own module, let me show you how easy it is. So here's the module structure, very similar to Metasploit, right? in the modules folder, it continuously queries any new module that you write. So it'll automatically get added structure-wise to it. So if you add a new module, it'll automatically show up in PTF. Additionally, it'll automatically add things to like tab completion and everything else. So you hit tab, it'll show it under modules and everything else. So let's just go to exploitation really quick, where set's going to be. And if I edit set, this is a module. So author, description, repository location, what specific platform you're using it for, and then any after commands you need to run in order for it to install properly. So it'll actually go through and do everything for you instantaneously, and you can see how easy that language is behind that to create a module. It doesn't create, you don't need somebody that's super sophisticated in programming to do it. Just to show you an example of like B, for example, which requires after actions, or after commands. You can see here I run after commands. I run cd, and then I have a path I put here for the install location. This is just, again, that language that I put behind it. And then it'll go in and install specific pieces of beef for you. That sounded awesome. So it automatically handles a lot of the automation that you need as a pen tester to keep a lot of your tools updated. And again, for me, it was out of necessity because I always wanted to have the latest and greatest. Now, granted, like all the tools that I use, I usually code myself. So like, I'm like, well, hey, do I have the newest version of Social Engineer Toolkit? Hey, let me try my Git repository real quick. But it's just a nice, easy way for you to be able to use a lot of those. Pretty cool? Yeah? That was the slowest start of a slow clap I've ever heard in my life. As usual in the Social Engineer Toolkit, I'm working on version 6.2, and I just released version 6.2, which I think was out about 2 or 3 weeks ago. And that was one of the largest updates I had done in a very long time. I rewrote a large portion of how the Java applet actually attacks the system itself. It does a lot of smart detection so that if PowerShell is on the system and it actually works, because a lot of people are disabling PowerShell injection, if PowerShell is there and it actually works, it'll then trigger a exploit that then goes through and does PowerShell injection techniques that drop interpreter real time into memory. So if that's enabled, it'll automatically go and do that. And so if it works, it will no longer drop binaries anymore. So it never drops a PE file, never touches disk in any way, shape, or form. So hopefully you evade a lot of those techniques. Additionally, the new Java applet I'm working on works a lot more efficient on detection around more of those next generation firewalls. A lot of the next generation firewalls are flagging on Java applets that haven't been seen or haven't been seen before. So there's a couple of techniques that I use to get around those. Justin Eltz gave me an idea for a new web attack vector using HTA files for exploitation, for browser exploitation. So I've been working on that. Really easy and effective way of getting access to a computer aside from it, because a lot of times, companies are starting to at least minimize how much Java is installed or lock it down a bit to only allowing certain applets. This is a method that you can use for compromise that doesn't involve any type of Java applet or Java to be installed in the system itself. So that's on version 6.3. That'll be out soon. And my favorite tool ever is Magic Unicorn. If you haven't seen that yet, it's one of the ones that I highly recommend. It should be in every pen tester's library. And I guess I'm a little bit biased because I also wrote this one as well. But Magic Unicorn is PowerShell injection on steroids. And if you're not familiar, everybody's hopefully moving off of Windows XP, and I hope so, because it's much easier for us to exploit Windows 7 and Windows 8 than it is Windows XP anymore. So with PowerShell, you can do anything you want to, which is phenomenal. It's a great tool for us as sysadmins. It's a great tool for us on the defensive side. It's also a great tool for us on the injection side. And so what Unicorn does is it's based off of a concept that Matthew Graeber came out with. He's probably one of the best PowerShell folks that I know. The guy is just absolutely brilliant. And he came up with a technique that allows you to inject native shellcode into memory real time through PowerShell injection. And so there's a problem with that when I was using this tool, or when I was coming up with this tool, is that in order to spray, for example, shellcode into memory, you either need to be, you either need to send 32-bit shellcode or 64-bit shellcode into memory, right? And so if I'm on a 32-bit computer, I need to know if it's a 32-bit or 64-bit platform or whatnot. So I created a universal way of getting access to a computer, which downgrades that process to an x86 process and then injects via that way with one native piece of shellcode. So it's a one-liner that you can literally copy and paste into a command line of a window, and it compromises the machine. So just to kind of give you an example. So we run unicorn, and it's a pretty simple command. Most recently, actually, I got a contribution, which is really neat. An individual, and the name's escaping me right now, but the individual that contributed added a new functionality which allows macro injection as well. So if you just add macro at the end, it'll create all the macro code you need to infect an Excel document. And then as soon as they open it up and enable macros, it does PowerShell injection on that Excel document and then compromises the machine without touching the disk itself, which is awesome, right? So if we run this, we run unicorn. It wants to know the payload, so we'll just use Meterpreter TCP. Now, the most recent version that I released about a week ago, I skinnied down the code itself significantly, and it supports now the reverse HTTPS and reverse HTTP payloads inside of Metasploit. Because if you don't know, if you look at the sizes of the shellcodes, the reverse TCP is significantly smaller than the HTTP and HTTPS. So this supports all of those now, which you can use all those different payloads. So if I run Meterpreter, reverse TCP, I'll just use TCP, and I got to grab my IP address. And then I'll do 443. It's an example. And it'll go ahead and create two files for me. The first is going to be a Metasploit RC file or a resource file, so I can just run my handler really fast. And the second piece is going to be that copy and paste shellcode. Now, where this is applicable at is anywhere that you have remote command execution on a Windows machine that has PowerShell. So SQL injection is a great example. If you get access to the XP command shell store procedure, literally you can just do a SQL injection command that has your one-liner PowerShell injection, then you get a shell coming back to you. It's magic. That's why it's called the Magic Unicorn. Or any other way that you have it. One of the most common ones that I use this for is if I compromise an organization and I get, let's just say, a local admin hash that I can use on the rest of them. There's a module inside of Metasploit called psexec commands that supports what's called rhost, which allows you to spray multiple IP addresses. You can run this, just one command, against an entire subnet. If you have those hashes, and all of a sudden now you have like 30, 50, 100, 200 shells coming back at you real time, and you're not dropping any binaries on the system. So if I run this really quick, so I'm going to run the RC file, which is going to create my handler for me. So I'm just running MSF console -r, and then unicorn.rc. And then over here, I'm going to go ahead and run my PowerShell attack. And this is the command line right here, okay? So it might be hard to see, but it just says PowerShell space. We do no profile, the window's hidden, non-interactive. And then we pass it this what's called encoded command parameter. And I think I've talked about this before, but I did a talk at like DefCon 16 or 15 when PowerShell beta first came out. And I'm like, man, PowerShell is awesome. It's really powerful. We can do all this stuff. And a few of the techniques for getting around what we call execution restriction policies. So if you have an execution restriction policy that's set to its most restrictive, this still circumvents it because we're using the built-in backdoor that PowerShell gives you called encoded command. So if I just run this, let me just run this real quick. We're still waiting for the, oh wait, over here. There we go. So I got my handler set up. So now if I go to my Windows machine, and literally I just copy and paste this. So that's the PowerShell command right there, right? I run it. Over here, takes a second. We get our shell. Magic. That's why it's a unicorn. So then we get access to that individual's computer through a specific method. Now again, deployment scenarios, it's endless because if anywhere that you can input command into, you don't have to upload a binary and execute it. You don't have to drop a payload that's going to execute a binary. You can stay strictly in PowerShell. One of the common methods that I use nowadays, I don't even actually use this one anymore. A lot of times for persistence, I'll embed all my code into the registry itself, and I just launch everything off of the registry now. So I don't have any files that say on the actual file system itself. I just run all of my backdoors and my persistence and everything else through predominantly registry itself, so I can just maintain access over a period of time. So those are the cool tools. Moving on to this, I showed a lot of cool tools, but I talked a lot about what we have in the industry. And one thing I see as one of the big problems out there right now in the pandemic is finding people in the security industry. I don't know if you know this or not, but the security industry is probably the hottest market right now that there is out there. It's growing about 300% each year, which is astonishing. And the problem that you're going to face, especially if you're coming in from a college perspective, is that there's an immediate need right now for extremely talented individuals, right? We need extremely talented individuals right now in the security industry, and we can't find them. So what we look for are extremely talented individuals, and then we have folks coming out through college that need mentoring, that need training, that need additional experience, but companies want someone that's experienced right now. So there's a gap right now between folks coming out of college and experienced individuals. So we're trying to, hopefully there's that gap that's going to be bridged where we can continue to train and move forward. We have to learn how to do that because there's a lot of gap right now in what we're actually hiring. Salary-wise, it's great because if you have literally like 6 years of experience, you're making 6 figures in the security industry. If you're not, then go find another job because you can easily find 6 figures if you have 6 years of experience in the security industry. So if you're not making 6 figures, you can easily go and do that with 6 years of experience. And especially on the red teaming side, on the offensive side. So, to just show you how big this is right now and what we're actually seeing as far as the industry. And wrapping things up here, when you look at the basics, to me that is where we need to focus our talks on. That's where we need to focus our industry at. We need to focus on what we're telling people because it's the basics that really work. It's something that's proven, it's known. It's something that continues to prove hard for us. If someone, if I'm doing a pen test and someone has done a really good job at the basics like network segmentation, password management, applications that don't have glaring exposures to the outside, education awareness, it makes it significantly more difficult for me to break into them. Significantly. I got to pull out my stuff folder, which is not usual. I have a folder called stuff that is like for stuff that I need to use when like there's like really cool stuff out there that I haven't exploited yet. And so I have a folder there that's just for breaking into stuff that that shouldn't be broken into in case I have to. It's like a last ditch effort thing. And so I don't like using the stuff folder, and that's great when I see companies that actually do basics because I have to go into my stuff folder. And one of the last things I'll talk about here is there's a big talk right now on a lot of folks, I guess people that are considered, I don't know what the best term for them are, or people that are well known, I guess, in the security industry, talking about adversarial simulation. And this is a really dangerous topic right now because we're telling the industry that they need to simulate adversaries, and that the way that we're telling them that the adversaries hack is through these amazingly advanced, sophisticated attacks. So we're telling companies that still have password 1 or summer 2014 as their passwords for the domain admins to then now have to figure out what a golden ticket is and how to detect a golden ticket. So it creates a damaging precedence for us right now because you're having these companies that are now focusing on these highly sophisticated APTs, which make probably 1% of the actual attacks that you really see out there. And now all of a sudden, we're supposed to be able to detect these super crazy advanced attacks. And so I stay cautious of these types of elevations. If your company can handle that type of detection, that's amazing. You're the only company I've ever seen out there that's been able to do that in this industry right now. So, get your dirty laundry first, build your programs first, then you can focus on the cool, sexy stuff of finding golden tickets or buying someone's product to help you do, better pen testing or whatever. So whatever it ends up being, okay? So, and then last but not least, this is the last one, I promise. Purple teaming, I always reference this in some way, shape, or form in one of my talks. And that's, the combination of a blue team and red team working together to really try to make a difference. And, what's interesting is our jobs are the same in the sense that we're trying to protect the company. Whether it's getting offensive to identify those vulnerabilities or identify those exposures, or it's on the defensive trying to protect the hackers from breaking in. We have to work better at communication. We can't have silos between these two groups anymore. They have to be like this. The blue team has to be part of the red team. The red team has to be part of the blue team. We have to understand each other in order to be able to defend. I learn so much when I do a blue team exercise within an organization because they have different ways of blocking that I would never thought of before. Same thing on the offense. When I'm going in and breaking on the offensive side, they find ways that I break in that they would have never thought they could detect on, but now they can. So we have to work together to understand each other to really build a more proactive way of defending against these types of attacks. Do we have any questions? No questions? I put a lot of stuff in your head really fast? That's what I do best. All right, we'll go get some, Jared, you're up next, right? Possum Man's coming up next. This is going to be an awesome talk, man. It's going to be an awesome talk. You want to stay for Jared's talk. Thanks, everybody. Appreciate you having me.